In our last video, we calculated the NPV of Lahore Sialkot Motorway project by using Microsoft Excel in three different ways, that is netting before and netting after approach, as well as using the formula approach, the formula which is here highlighted in the formula bar. Now we will get to the other discounted measures of project worth. The next one that comes in our mind is the BCR, the benefit to cost ratio. It would be easy by using this table that we have developed in the last video, because what we need for the benefit cost ratio is the ratio of the discounted benefits and the discounted costs. Here you can see we have a discounted benefits column here, and we also have the discounted cost column that we used for the netting before approach, discounting before approach, where we discounted the benefits and the costs before the process of taking the difference or before netting them. So this is just a reminder of how we calculated these values, that is the discounted cost, multiplying the discount factor with the costs, and here multiplying the discounting factor with the benefits. So in this way it was calculated, just verifying the formula from the last cell as well. It is not correct here, so we have to fix it, because the discounting factor should be multiplied with benefits. Here it is correct, but in this cell it is still correct. So now we are assured. We had that impression that it's not correct, but now we are sure that it is correct. Just to make sure, let's copy paste this correct formula in all of the cells, and we get the verified version, the benefits and the discounting factor getting multiplied. Now I should take their sums, because I need their sums so that I could divide them. So equal sign sum, bracket start, choosing all of these and then closing the bracket should give us this sum. So we have found the sum. Here I can copy paste this to make things easy, and I will get the same thing that I want for the discounted benefits. The sum of the discounted benefits is calculated. So after calculating these two, I can now use them for the sake of calculation of the BCR, which should be greater than 1 for a desirable project. Here let me show you the formula that I have developed. This is the formula. I could have chosen these two values, their ratio. That is, instead of writing these sums, I could have written equal sign discounted benefits, their sum, divided by the sum of the discounted costs, and in this way the answer could have been calculated. But the other formula that I used before is slightly different. This is that formula: sum of these values, that is the discounted benefits, divided by sum of these values, that is the discounted costs. So I can apply this formula, or I can calculate the sums here just like I did before, and then I can take their ratio. Either of the ways I'm going to get the answer which is the same, which is 1.6327, which means that it is a desirable project, and you can see it is visible here, the feasible project. So in this way BCR can be calculated effortlessly by using a simple formula of ratio and sum. And then we have NKR, the net benefit investment ratio. We can also calculate this. It is similar to BCR, but definitely not the same, so the formula should vary. We will take the sum of the positive discounted net benefits and divide it with the absolute value of the sum of the discounted negative net benefits. I mean, I can do it by simply, I can write this formula here for you: the sum of all the positive discounted net benefits divided by sum of the negative net benefits, and I get a negative value. And you remember that we learned in our manual procedure or process that the negative values to be omitted, because we are comparing the magnitude of the two favorable and unfavorable discounted net benefits. So for that, what we can do is we can remove the sign, the negative sign. For that, absolute operator is used, ABS, and as soon as I write ABS, it says that it returns the absolute value of a number without its sign. So this is what we want. We want to get rid of the negative sign of the terms from L2 to L4. So when I close it in absolute operator, it is going to give me the positive answer. So this is how we can calculate the NK ratio. But I came up with a better formula here that we can use, and I will show you here. I have basically used a condition sum under the formula of sum if. It will only sum if a certain condition is fulfilled, and the range for which we are applying this formula is from L2 till L11. That is all these discounted net benefits cells. But the criterion is written afterwards. As you can see below, its range that we are talking about, then comes the criteria that we are, or criterion that we are dealing with. In double quotes I am closing it, and that is it should be greater than 0. So it will sum only if the values are greater than 0, or in other words, the values are positive. So all these values that are positive here, that is starting from 10.1683 till 13.8448, it will give us the sum, and then I divide it with the absolute sign of this sum, that is no negative sign will be there, and this sum will be actually a conditional sum. It will sum all those values from L2 till L1 that are fulfilling the criterion that they are negative, that they are less than 0. For and definitely the values from minus 17.8571 till minus 14.2356, they will be selected, and then if I enter, I get the same answer as I got before by using that more of a manual approach, whereas this is more of a automated approach, because it figures out those values that are negative and positive and sum them separately and then take their quotient. It is also suitable in a situation where the values are not in a tandem, that is the negative values, they can reappear. For instance, if there is a negative value here, that is I just enter a negative value, as you can see, the answers are now different because the sequence is now broken. This formula is giving us the correct answer because it is considering those values that are negative regardless of their sequence. It is not going to choose only the first three negative values, but it is going to, rather it's going to include this value as well. So this gives us a correct answer. Whereas if I depend on that formula that was more of manual in nature, still you see that we are summing these values in the blue highlight, and minus 12 is being added in it. So when we add minus 12, it will be actually a subtraction from the sum of these positive discounted net benefits. So the answer will be negative. Therefore, before I conclude this, I should see that this sum of the negative values, as I can see here, it's only including these three values and it is overlooking minus 12. So the mistake is not just in the positive discounted net benefits, but also in the negative net benefits due to this formula. So for such unconventional stream of net benefits that are not following the traditional flow where the negative net benefits appear in the beginning and the positive net benefits appear in the preceding values or at the end of the project, we cannot use this formula. So this formula is definitely not our favorite choice. This is the formula that is unlikely to fail no matter what sort of unconventional stream comes our way. So I'm going to resume this, and you can see the answer is automatically updated. and when it comes to its interpretation, it is still the positive, it's still a value greater than 1, and definitely we can say that it's a feasible project, not just verified by these three, by NPV, by BCR, but also by NKR. All three of the indicators are telling that the project is desirable. We don't see any PKR here because this is a ratio, and we should not format it in a way which is going to be having some numeric currency units. So it's devoid of units, and it is how it should be. So we haven't introduced any currency units. In this way, we have learned how to calculate BCR and NKR with formulas that are unlikely to fail. Thank you.